Equation is f raised to the n over n factorial times x minus c raised to the n. N is equal to the derivative, or whichever derivative number you're on, and c is equal to the center. Take f of x. Do the first derivative, then the second, third, fourth, etc., until you reach the number of degrees indicated or number of non-zero terms. Here's an example. E to the negative x squared. Find the 6th degree polynomial. So you could do it two ways. You could either do it the way we discussed before by doing the derivatives, or we can do what we already know from the car. So we know e to the x. We know the series for that. It's n equals 0 to infinity. So 1 over n factorial times x raised to the n, and then it factors out into 1 plus x plus 1/2 x squared plus 1 over 6 x cubed. So now you're going to plug in negative x squared for every x. So now from e to the x, it's going to become e to the negative x squared. So 1 plus negative x squared plus 1/2 times negative x squared plus 1/6 times negative x squared cubed. So once you work it out, you're going to get 1 plus negative x squared minus 1/2 x raised to the 4th minus 1/6 x to the 6th. And you stop here because it told you to only find to the 6th degree polynomial. So this is your answer.
We use the formula Rn of x equals the max of the absolute value of f raised to the n plus 1 z divided by n plus 1 factorial times x raised to the n plus 1. For example, we'll find the Lagrange error of the 4th degree Taylor polynomial for f of x equals cosine of x about c equals pi over 6 when x equals 0.5. So we'll start with r sub 4 of 0.5 is going to equal the max of the 5th derivative of z all over 5 factorial times 0.5 raised to the 5th. So r sub 4 to the 0.5 equals the max of negative sine of x, which is the 5th derivative of cosine, all over 5 factorial times 0.5 raised to the 5th. This equals 1 over 5 factorial times 0.5 raised to the 5th, which equals 6.099 times 10 to the negative 11th, and that's Lagrange error.
Raised remainder. This is the formula that we were given in class. The absolute value of s minus s sub n equals the absolute value of r sub n, which is less than or equal to a sub n plus 1. This formula isn't the one that we used in class to solve the problems, but if you are a formula person, this is the one that you would use. What's necessary to write on your AP exam is what you always have to start off with to get credit, because it is a convergent alternating series. This has to start off your answer to every single one of the alternating series remainder problems. Then you'll say the first neglected term, for example a sub 3, is equal to some fraction which is less than the remainder they asked for in the problem. So for example, natural log of x squared plus 1. Determine the rational number a such that the absolute value of a minus the natural log of 5 over 4 is less than 1 over 100. So the first thing you look at is 1 over 100 is the remainder that they gave you. The second thing you have to do is solve for the x so that you know what to plug in to get your fraction. So in this case, 5 over 4 is equal to x squared plus 1 when you look back at both of the problems they gave you. So then you're going to end up solving for x, and it's going to be x equals 1/2. So the third step is to write out your Taylor polynomial, and then the next thing to do is plug in the 1/2 for every place you see an x. And when it simplifies, you get 1/4 minus 1 over 32 plus 1 over 3 times 64. Now this term we know is going to be less than 1 over 100, which is the fraction they asked for in the problem. So you know that a sub 3 is the first neglected term. So once you figure that, you can write the answer, starting with because it is a convergent alternating series, the first neglected term, a sub 3, is less than 1 over 100.
Things that you have to know for the AP exam. The first one is the p-series test, and it looks like this: 1 over n to the p. If p is greater than 1, then that means it converges, and if p is less than 1, it diverges. The second thing is the ratio test to find the interval of convergence. And when you do the ratio test, you do the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And when you simplify all that and find the limit, then you get something that looks kind of like this. The absolute value of x minus 1 is less than 2, where your center is at 1 and your radius of convergence is 2. So your interval is negative 1 is less than x is less than 3. And so once you get that, you have to check both endpoints to see which converge and which diverge. The third thing is the geometric series, and it looks like an exponential function, x raised to the n. If x is less than 1, it converges, and if x is greater than 1, it diverges. To find the sum of the geometric series, you plug into the formula a sub 1 over 1 minus r. The fourth thing is alternating harmonic series, and these are three main examples of those, and those always converge. The fifth is the harmonic series, and those look like this, and those always diverge. The sixth is the alternating series test, and if both of these apply, then it means that it converges. So now we're going to do an example. Which of the following converges? So when you look at these three problems, you can automatically tell that this one will diverge because 5 over 4 is greater than 1, and that means that it diverges. And then for these two, you have to do, for this one you have to do the integral test, and when you solve that out and you plug in infinity, you know that it diverges because infinity diverges. And then for this one, this equals arctangent of n, and when you do the arctangent of infinity, it equals pi over 2. So pi over 2 minus pi over 4 is pi over 4, so it converges. And then for this example, what are all values of x for which the series negative 1 raised to the n over natural log of n times x to the n converges? So for this one, you have to do the ratio test, and it looks like this. So you do that limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And when you solve all that out, you get the interval of convergence of x is greater than negative 1 and less than 1. Then you need to check the endpoints, so you plug that into your original series. So when you plug in a negative 1, it makes this not alternate, so it diverges. And then when you plug in a 1, it alternates, so it converges.